This is the second question I'm doing to assist my former student with his revision for finals. Again, we have a fraction to integrate. This time we're integrating between two limits, 2 and 1. So this is an example of a definite integral. So we do not need a constant of integration once we are integrating between limits. You will notice that this fraction is also of the form f prime x over f of x, just like the last question. And of course, you should recall that that result was equal to f of x plus a constant. Right? Now this, of course, is for indefinite integration. Since this is a definite integral, we won't be needing the constant of integration in this case. Coming back to our problem, so we're going to integrate between 2 and 1 the fraction x over x squared plus 1 with respect to x. And again, we will notice that the first derivative of the denominator, which is x squared plus 1, that is going to be equal to 2x. Now, is 2x a scalar multiple of x? Yes, it is. It's x times 2. So what we need to do to use this result, f prime x over f of x, we need to get this in the exact form of f prime x on f of x. It's not currently in that form. To get it in that form, we need to have 2x up here. So the derivative of x squared plus 1 is 2x. So we multiply x by 2 to get 2x. Now, of course, if we multiply inside our integral by 2, to maintain equality, we need to multiply outside the integral by the reciprocal of 2, which is a half. So we just multiplied by a half times 2, therefore we did not change anything. But that adjustment was important because it allowed us to get our integrand in the form f prime x over f of x. So the next step, we are going to integrate. So this will be equal to a half times x squared plus 1. Note that we do not need the constant of integration because we are evaluating between 2 and 1. We have two limits to integrate between. Good. So just to summarize again, the integral of 2x divided by x squared plus 1 is equal to x squared plus 1. Good. Now we need to insert our limits. So the next step, the next line will be, so it's equal to a half, open bracket. So anywhere we see an x, we're going to replace it with a 2, and then afterwards with a 1. So 2 squared plus 1, that's where we substituted our 2, and then we're going to minus, and we're going to evaluate the integral at 1. So wherever we see an x, we're going to replace it with a 1. So 1 squared plus 1. And this is equal to a half into 2 squared plus 1, that's 5. So our first square bracket evaluates to 4 plus 1, which is 5, minus, so it's always f of a minus f of b, where a is the upper limit and b is the lower limit. 1 squared is 1, 1 plus 1 is 2. So we get 5 minus 2. So in this bracket, we will have 3. And remember to multiply outside by a half. So a half times 3 is 3 over 2, or 1.5. And that is the integral of x divided by x squared plus 1 with respect to x.